All right, thus far we've been looking at using resistors to load our transistors, and we found that our gains are proportional to transconductance times resistance. In an IC, resistors are typically too big, so we try and use transistors as active loads. And let's look at the reasoning for that. So I know that the gain for this common source amplifier is equal to minus GM times the quantity RD in parallel with RO, where RO is the output resistance of the transistor and GM is the transconductance. Now, for high gain, I know that I have a couple of choices. The first is to try and raise GM. Now, I know that GM is equal to 2ID over VOV in one form, and so this tells me increase ID. So I want to increase the current flowing through the device, and if I do that, I'm going to have a bigger voltage drop across RD. Now, if VRD is too large, the drop across that resistor is too large, it gets difficult to keep the MOS saturated. So then we know we have another choice. We can try and increase RD, the drain resistance. We note that this really results in the same problem. If I make RD bigger, even at the same current, then the voltage drop across the resistor is bigger. Now, on an integrated circuit, we have another problem, and that's that resistors are typically big on an IC. So even if we want to use resistors, they're going to be fairly large geometrically in order to achieve the resistance we want. So we can ask, why are resistors big on an IC? And typically it's because we use some high resistivity material. This can be something like an in-well or unsilicated polysilicon. Or other types of materials that have a high resistivity. And we make things like these serpentine structures shown here between points A and B. So there's some material here that we're using to connect points A and B that's got a high resistivity. So we model this as a physical, this physical material as a resistor that's got some resistance R in the connection between points A and B. Now, if we want to increase the resistance, we just need to make this longer. We're going to make the serpentine structure longer. But even to get just a few kiloohms, this can be quite a big structure. So it's not necessarily a good choice when we're doing designs on integrated circuits. So next we're going to look at what type of active load is ideal on an integrated circuit. And we'll do that in the next video.